All right, so we're back, and in this video, we're going to be looking at using the sweep command. So I have created a few different scenarios here. Each one of these have circles. Let me throw this into 3D real quickly. One of the circles is stood up so that it's vertical on the z-axis. The rest is just a regular 2D flat pattern. So the first box here has individual lines. The second box, the lines are all joined together. The third box has filleted edges with a flat circle, and the fourth one has filleted edges with a circle stood vertical. So in this video, we're going to be looking at using the sweep command here. And with the sweep command, what that does is that converts your 2D flat drawings or lines into a 3D solid, and it sweeps the shape you want around an axis. So in this particular case, what I want to do is I want to sweep the circle shape. So I'm going to select the sweep command and select the circle shape and hit enter. And then it says select your sweep path. So I want this circle to now sweep around this pathway. So in this case, each one of the lines are individual. So I select on one of the lines and bam, it just shows the sweep around that one line. So you can see there that it has now converted that circle and that line into a 3D solid. If I go in there and delete that 3D solid, it's now deleted my line and my circle as well. So let me undo that. Actually, I'll leave that up. The next one here, I have joined together each of these lines using the join command, and I have the same circle and I have now the same box. I'll use the sweep command. I select on my circle to sweep and hit enter. It says select your sweep path. I select the box joined together. And now, as you can tell, it sweeps that shape in around that entire box or pathway. Not box, I'm sorry, rectangle. Box is for a 3D shape and rectangle is the 2D drawing. If you want rounded corners, so notice on this rectangle here, it has square edge corners. And so it breaks that pipe or that rounded piece there about the 90-degree corner. If you wanted it to be rounded off, I have made a rectangle. I've filleted the edges, and I have the same circle. So here, I'm going to now use my sweep command, same circle, press enter. By the way, if you use AutoCAD a lot, keep your thumb on the space bar or, one hand on the keyboard, one hand on the mouse. And what you'll find is space bar is the same as enter in AutoCAD. And so you can quickly and easily hit the space bar as the enter key. So I've selected my circle, I hit enter, and now it says select your sweep path. And so I'm now going to select this. And now it has this pipe look where the circle is swept around the that rectangle with the filleted edges. That does the same in 2D. Let me undo that. Okay. It will be the same as in 2D as it is in 3D. So if I do the sweep, that circle, keep in mind I stood that circle up. It was drawn on the XY axis and I stood it up so it's vertical in Z. And if I hit enter and select my sweep path, it comes out with the same design. So one of the nice perks about using the sweep command, you can draw those in 2D and you don't have to necessarily move your object up. Okay, so it does the same thing. It just simply takes that shape and then sweeps it about the axes there that you dictate. So that is the sweep command. Now, with the sweep command, it is very functional and useful for creating more advanced geometric structures, for example, like threads or like springs. So I'm going to go back to my home tab here. I'm going to go to my draw command, and now I'm going to use the helix. So if I use the helix, and let's say that I put my helix out in a cone shape, and let's change the turn height, not the turn height. Let me change the number of turns to, let's say, 20. Okay. So now if I draw this up, now I have this helical shape. Okay. So this is where you'd see springs, for example, being able to draw it, but these are single lines. If I do a circle and draw a circle down here and then do my sweep path, let's go back to sweep, and I want to sweep that circle about this item right there. of course, gives me a little modeling error. Let me make that circle a little smaller. Sweep that circle about that path there. It now creates this spring effect that I can 3D print springs, I can 3D print coils, what have you. The reason it gave me the error was that circle, whenever it sweeps around this axis, it was going to crisscross over itself, and so it created an error for the system. You got to have a little gap between each one of the coil heights. Okay, so that's how you could create a spring. You can also do this to create threads. As we look at doing this to create threads, we're going to go in and we are going to bring up the Helix coil again. In this particular case, we're going to be making sure that our bolt is the same size diameter at the top and the bottom. We'll do a sample one here. Let's say, for example, a quarter 20 bolt. That's a standard size. The major diameter is a quarter of an inch or 0.25. The 20 stands for how many threads are in 1 inch. So that would be 20 threads per inch. So I selected my Helix coil here under the draw command. Now I'm going to type in the diameter. Notice it defaults to radius, so I'm going to hit D for diameter and hit spacebar or enter. Now I'm going to simply type in the major diameter. So 0.25 is the major diameter. And now it says specify the top radius. Okay, so if you want this to be all one diameter, okay, so the bottom of it and the top of it to be the same, you would need to either retype in the same number or simply hit enter again, and it will input it. As you can see here on the information bar, that it's already defaulting the radius as 0.125, which was what I just put in, or diameter of quarter inch. In this case, you need to specify your number of turns. In this case, I'm doing a quarter 20 bolt, so 20 threads per inch. So I'm going to type in 20 because I'm going to do a 1 inch span. If you were doing this for a 2 inch span, you would want to double that to 40. So in this case, I want to tell it how high, and we are going to go 1 inch high. And by the way, before I hit this, real quickly, there are other options. So you can do the number of turns, the turn height, the twists. So there are some other features that you can use there. But I'm going to hit it 1 inch high. And now I have this coil. And with this coil is now a quarter inch diameter. Excuse me. It's quarter inch diameter and has 20 threads. So now what I want to do is I want to draw the outline of my thread. So in this case, I'm going to snap here. Now, if the threads are 20 in 1 inch, that would mean the thread step from one to the next would be 0.05. In this case, if you type in 0.05, it will error on you, just like we saw with the spring, where it'll want to lapse back over on itself. So in this case, I'm going to go just a little bit shorter. By the way, if you really want to get into the detailed thread specs, let me just show you this here real quickly. I'll grab and pull this over. So this is just one example. You can research thread diagram. Here, the darker gray is the internal thread and the lighter gray is the external thread. I know it's a little pixelated there on the screen, but you can actually go in and calculate all these up. So standard UN type threads, so Unified National type threads are going to be 60 degrees. So you could get into technically calculating this up. Notice that there's going to be a little bit of gap right here. There's going to be a little bit of gap right here. So your external threads and internal threads have a little bit of wiggle room. We don't get into all the details there. That is a little bit beyond the scope of what we are wanting to look at. And so here for threads, you can just suffice to simply draw in a thread to be close enough. I've noticed, especially if you get into 3D printing threads, for smaller threads like these, you really need to run a tap and die set through them just to clean them out in case they have any little plastic burrs and gunk left over from the 3D print process. The 3D printers, depending on your type, may have a little bit of that slop in there, okay? So just a heads up there. If you're making really large threads, you will want to add in or subtract out to give it a little bit of tolerance between the male and the female thread. So again, like I said, if I were to go up from one height to the next for the turns, that distance would be the 1 inch divided by 20 threads per inch gives us 0.05. I'm going to make that a little bit smaller. So if I type in 0.0, I don't know, 49, okay, that'll be just a little bit shorter. In this case, the thread coming out, you can get close with that thread coming out. There's a chart that tells you how to calculate the height of the thread or the pitch of the thread versus the height versus the depth, all those things. But you can get it pretty close coming out 2/3 or so. So we'll just punch that in at point, I don't know, 3/8. There we go. That looks close enough. So now I'm going to delete these pieces out. I need to join those lines together. Don't forget to join them. And so now whenever I go up here to the solid, I'm going to sweep this object over this axis. And it will okay. So that gives me an internal thread. That is one way you can do internal threads. In this case here, let's move this or rotate this about 90 degrees. So if we do a rotate along this axis at 90, and then let's go ahead and move this back into place, the outside going to the tip there. Now when we go to sweep this object here, we're going to go back in, solids, sweep our lines, and that gives us external threads. Okay, either way, you can cut those in. Notice here that because there was nothing going to the center, this is now a hollowed out object and it just has the threads. In this case, an easy fix would simply be to add a cylinder. You could come in here, do a cylinder, put that cylinder in, and join those together. Okay, so that shows you there a little bit as far as doing an internal thread or an external thread. You can also go in and subtract the thread out. So making the male thread here and putting that into a larger cylinder and then subtracting it, and that will cut out your internal threads as well. So just a couple of features there that you can do with threading. And once again, you would be using the draw Helix command. You'd be drawing the triangle and joining it together, and then you would use your solid sweep where you're sweeping that joined triangle along your Helix path. As always, please let me know if you have any questions. I'm here to help you, and good luck on your next assignment.